My name's Sean Tibor. I'm a coder who teaches.
And my name's Kelly Schuster-Paredes, and I'm a teacher that codes. We have
Right.
opposite roles.
so so we started teaching together about 3 years ago, Kelly and I. And I'm going to introduce her real quick, and then she's going to introduce me. We find it's kind of fun to do that because that way we each don't know what the other person's about to introduce us as.
But I go
So,
first.
oh, you get to go first? Okay, go ahead.
You flip the other slide. So in
Okay,
case
here
I
we go.
forget who you
Here we go.
are. No, I'm just kidding. So yes, I met Sean 3 years ago. He demoed in my classroom, took over the classroom and started teaching microbits. I had been told 2 months earlier that I was about to be teaching Python, and I am not a coder. I played with robots a little bit and I helped tech integration, but Sean was, sorry, I'm taking my role, but Sean was from digital marketing and had never taught before. And when he came into the class to do his first lesson, we had a lockdown, a real lockdown, and he was crawling underneath the desks and making all the kids feel very calm. And we just knew right away that he was going to be a great teacher for us. He's a great coder. He's a geek completely, and I have to tell him to stop geeking out all the time because he loves everything about coding and hardware and is always learning. So that's my buddy.
Well, let me introduce you to Kelly Paredes. She is someone that has become a great mentor for me in terms of learning how to become a teacher and how to teach more effectively. I mean, even just yesterday, she and I were talking about the finer points of a lesson that I was giving, what worked, what didn't, how to make it a little bit better, more engaging, more useful and valuable to the students. But she comes from a rich background of teaching and pedagogy. She's the consummate teacher, really cares deeply about students, but also cares deeply about the design of things, how we teach, what are we really trying to teach. And this is her third year coding, and I have to say I'm always so proud to see how far she's come. I mean, I help her where I can, but she is persistent, she's determined, she wants to figure things out. She's like, I'm just going to tell you this, but don't tell me the answer because I want to figure it out. She's that kind of person who wants to figure things out, whether it's teaching or coding or curriculum. She is deep into all of that and loves to do it. And together, Kelly and I host a podcast that comes out about every other week, depending on how busy we are, called Teaching Python, where we talk about these things that are interesting to us, the conversations that we're having in and outside of our classroom about coding, about teaching, about the students, about the bigger picture. And so we talk a little bit about where we teach now. Kelly, I'll turn that over to you so you can share a little bit about the context of where we're teaching.
So we don't teach in an international school, but we still teach in an independent school. So hopefully what we have almost the same demographic as a lot of the international schools. We work in Pinecrest, Florida, or Pinecrest School in Fort Lauderdale, Florida, not in Pinecrest. And it is an independent school, PK-12. So as some of the other international schools that I've worked at in the past, we have that coding curriculum or that from PK to 12 kind of atmosphere where the kids are at least learning some sort of computational thinking. And it's a nice curriculum that kind of flows through the school. But there's always the ability to develop more and do better. And that's something that we are constantly striving to do at Pinecrest, is to make our curriculum better, just like most teachers want to do.
So what we teach, and this is where we're going to get into kind of the core of our topic today. Kelly and I teach Python, which is a high-level programming language. It is one of the most popular programming languages today. It's one of the fastest growing. And we describe it as a full spectrum language. So it's easy to learn, but it makes it possible to do really hard things. And it's used everywhere for beginners to learn how to code, all the way up through most of Instagram is running on Python as its programming language. It's used in machine learning and data science, artificial intelligence, but there are places where it doesn't go, and that's okay. No language can do everything. But what we found as we've gone through this process of learning to teach and learning to code was that what we weren't really teaching was Python. We were teaching more durable skills, things that lasted, things that persisted, those things that students can take with them long after they've forgotten everything there is that they've learned about Python. There are things that are going to stay with them. And so Kelly, I'll let you take the first one here.
Well, before I jump in onto the first one, I just want to I don't know if you guys got the opportunity to go to the keynote with Will Richardson today. I've been following and stalking, on Twitter, Will Richardson for a while now. I saw him in Sao Paulo years and years ago. And I just love his idea of the 9 questions. And it's something that's been permeating my teaching, this making curriculum that's not forgotten. Kids often forget Python. They forget coding. They don't understand why do I have to learn coding? And we've been trying over the past 3 years to really mutate our curriculum to make, like Sean said, these durable skills that stick out, and play with the idea of Python being the platform through which we teach our skills. So something that really stuck with me, and I was thinking about this while Will was talking this morning, is what is sacred? What is sacred about our curriculum? And I think, and I'm hoping that you guys can share some thoughts while we go through these, but these 6 things we chose as the sacredness of our curriculum, things that we want to keep. So the first one is this mindset awareness. I know Carol Dweck, she talks about mindset and really getting the kids into having this motivation, this growth mindset. And so as we're teaching Python, a lot of the kids will come into our class and just say, I can't code. I'm so confused. I don't know what I'm doing. And that puts them on this closed mindset, this fixed mindset. And what we have really taken into heart this year is, how do we change that mindset and make them aware of the vocabulary that they're using, of the fear of failure, of the thing that I'm giving them feedback, but it's not meant to be hurtful, but it's meant to be helpful.
Right. So, and the other thing that I would say too is that closed mindset, that I can't do it, comes from so many different places. It comes from inside the student, it comes from outside the student, it comes from all these different places. But that feeling of I can do this comes from inside. It's something that we can say to students as many times as we want, but the way that it sticks is when it comes from the inside. So we have this ladder structure that we found that we really like, that you can see on the screen here, where we talk about stages of capability, like altering your mindset over time, because most people can't just flip a switch and say, okay, I'm going from I can't do it to I will do it, and I've done it, and it's great. Like, it takes time to build that mindset. And we help our students recognize that there are many steps along that way to that I can do it, and that it's okay if they go back and forth a little bit. If you take 1 step backwards and then take 2 steps forward, you're still making progress. And so we want them to be aware of this mindset as they're coding. What mindset are you in right now? And so some strategies that we often talk about between ourselves, and we also make very visible to our students. One that I love is just reflection, right? To be able to talk and say, where were you? Where was your mindset when you started this? And what is your mindset now? And having that conversation with them where they can reflect and think about the progress that they've made on this, and identify those steps where they maybe went back and then went forward again, and where they had those challenges. Just the act of reflection makes this much more aware. It makes them much more aware of this. And that's something that they should be doing with nearly every project that they have.
We go to the next slide, and feel free to ask us a question and stop. Otherwise, we'll just kind of keep talking. we talk a lot. But the other strategy, and this is something that Sean taught me when I was first learning how to code, the power of yet. I would say, oh my gosh, I just can't get this. And he would say to me, you just can't get this yet. And over the 3 years, we've been really helping the kids just use that simple word yet, and just the power of what it does. I don't understand math, or I don't understand math yet. Algebra is really something that's confusing me. Well, algebra is something that you don't know yet. And so we like to switch that and change that vocabulary. A lot of the times we always say, let the kids fail. We celebrate failure. We wanted to do a high five wall, but because of COVID, we have ultrasonic sensors so the kids can go up and, celebrate that failure with a smiley face popping up. Things that were going to help them to understand that it's our process over the end product.
Yeah, and we change the vocabulary with them too. We talk a lot, not just yet, but we talk a lot about, having this forward thinking mindset that failure is not the end, right? It is a step on the path to success. And we all, if you think about your own life and all the things that you've done, right? Along the way, if you counted it up, you've probably failed more times than you've been successful, right? So this idea that, failure is part of the process and that it should be part of your vocabulary to be able to say, I failed and that's okay. I failed this iteration. And to start getting them to think about that iterative mindset where failure, 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 if you keep failing forward, eventually you will succeed.
And just a quick on the benefits that I'm sure you guys can come up with tons of the benefits, but the one major benefit is that it hooks students. And then I'll let Sean go to the next slide.
All right. So Kelly and I talked about this a lot. Like, how does curiosity fit into this framework? Because curiosity, I argue, and she views a little bit differently. Curiosity, I don't think is a skill. It's a trait. And it's something that you can enhance and you can encourage and you can foster and grow, but it's not necessarily a skill. It is something that many other skills benefit from. So what we want to do is take students' curiosity about things. We want to spark it, we want to ignite it, and we want to use that curiosity to help them find motivation, to find intrinsic value in the things that they are learning. Just ask those great questions that lead them on their own path of learning in their own directions that they can choose and select.
But so I argue that so we both of us agree that we leverage that curiosity, but we want those kids and hopefully we want those adults where they are curious for the sake of knowing. And imagine hiring a teacher who's curious about learning, or curious about why we code, or curious about a new method of learning math. For me and for Sean, we want our kids to be curious about everything. So we try to model that where, we're always getting new books, we're always trying new things, and we're always trying to program new products, even though sometimes I do a lot of failure with my products coding, but we try to build that curiosity and model it.
Yeah, and we also ask a lot of questions. I think in our classroom, we probably ask more questions than we answer, right? That process of questioning, what are we learning? What's in here? What does this thing do? How could I make it work better? That process, I think that, asking good questions, that to me is the skill, right? It leverages the curiosity, but knowing to ask questions and what kinds of questions you can ask and what kinds of questions, are there any questions that you shouldn't ask? And making it okay to have that questioning, curious mindset is really great. And we do a lot to couple that with this idea of playfulness, right? That we are playing with technology, that we're having fun. And it's funny because, coming from a non-teaching background, I talked to some of my colleagues that I worked with in technology and marketing and everything, and they say, what's it like being a teacher? And I say, I get to play every day. I'm playing with code, I'm playing with technology products, I'm playing with robots and VR, and what I try to do is bring as many of my students into that spirit of playfulness as possible, right? And that also encourages and makes failure okay. So it ties back to that idea of failure, because when you're playing and something fails or something doesn't work the way you expect, it doesn't become onerous. It doesn't weigh upon you. It's just part of playing is that you have fun and you can laugh it off and move on to the next thing, and failure becomes part of your play instead of something that you try to avoid.
And then the other thing, and just thinking about your classrooms right now, we tried pre-COVID, obviously, we're having issues with the COVID and wiping and cleaning robots and all of our toys, but we always make our products available. If it's on a top shelf, if it's hidden away, if it's in a closet, the kids aren't going to be curious about it. So we often will unbox products. We'll put board games out. We'll turn the VR, AR machine, the virtual reality machine on when we could. And we like to bring it down at their level. Everything is in an eye level of a sixth grader, a seventh grader, eighth grader. And it's just this ability to have the kids go, what is that thing sitting on the, and normally it's me saying that's another one of Mr. Tibor's robots, but go ahead, you can break it. And just having that ability to let them be curious about those new products. So,
and that is contagious. An example of this, I found a project plan for how to build your own lightsaber. You 3D print the handle, you code the electronics, you do a lot of soldering. Like for me, it was a really good, meaty project. And I made this lightsaber and it was a lot of fun. It was my playtime project. And I originally had this plan for what I was going to do with it, and that fell through due to COVID. But I just left it in the classroom. And one of my students came in and said, "What is that?" And I said, "It's a lightsaber. Check it out. You can turn it on. It makes sounds. It lights up, the whole thing." And he said, "I want to make that." And so well after the course is over, he has been building his own lightsaber. So he just came in a couple of weeks ago and showed me how he had painted the whole thing and then added weathering to it. So it looked like it was old and authentic and everything. And he was super proud of it because he was seeing that play. And so play can be contagious, which is probably the only contagious that we want in today's environment right now. But play is a good contagious. Okay. But let's, Kelly, this one's yours.
Yeah. So I'm not sure if any of you know Barbara Oakley or if you've ever followed her Learning to Learn courses and mind shift courses, but she talks a lot about using metaphors and being able to put these huge concepts, these huge topics into metaphors and to images. And that was something that I really started to take to heart when I was learning how to code. Coding was not natural for me. It has been a long struggle learning and teaching Python. I never in the million years, 3 years ago, thought I would be at that spot. But every single time when I'm either watching Sean teach or I'm learning from a course, I'm trying to put things into metaphors. And I know that by giving kids whiteboard markers, by giving them things that are tangible, that they can remember in their mind, they can then start to associate this code, this thing that they can't really see, that thing that happens in the computer. They start seeing images and they start making connections. So the use of metaphors and images really crystallize that understanding. And that child that can build images and that can build metaphors is a child that can get and manipulate topics and information. So strategies.
And just to know our audience a little bit, how many of you here know how to code already? If you can just raise your hand, you can use the little raise hand icon in the participants window, I think it is. Just raise your hand if you know how to code already, if you've done any coding in the past. Okay, so we have Patricia, Elisa, Jorge has coded before, Johanna. So if you've ever tried to teach someone else how to code, that idea of like you have your own mental framework for how coding works or how this particular thing works or this concept, trying to explain that to someone else that hasn't coded before is, I think, almost impossible without some sort of use of metaphor and imagery, visualizations, ways that they can relate it. And this is particularly effective in the coding realm because so many of the concepts we're talking about are abstract. or if they're text-based, it's hard to explain the text and turn that into a mental image of the concept that we're trying to teach. So we end up using these metaphors and images a lot. And one of the key strategies that we've employed is to make as many spaces in our room writable as possible. So we have tables that are made entirely out of whiteboard material. We've asked to have all of our walls painted with whiteboard paint so that literally any surface can be something that a student can draw on, can quickly sketch out a note to create that imagery. And then the other thing that we do, and this is particularly important and a key watch out, when you use metaphors, you have to be very mindful of equity and diversity, because the metaphors that may work really well for one student or one group of students may not be effective for a different one. So we end up using multiple metaphors, give them many different things that they can relate to. So if there are 3 different metaphors that they can latch onto, at least one of them is really relevant, right? And we try to encourage a diversity in our metaphors as well.
Yeah, I mean, just thinking about those of you that code, we know the variables, putting variables in, the objects inside of a box. That's a very common metaphor that's often used in computer-free environments or offline teaching lessons. Here's my box. We're going to put this item in our box. This is our variable. It holds this item. We do things like that, and then we will physically move things. Just doing those, those little things that make those abstract concepts really tangible. The last thing, just to give that side note, if you guys do, or if you're back in the classroom, really embrace the plexiglass. We've loved the plexiglasses that's separating our desks because they become another writing space.
Right, right. And then the other thing is, if you're struggling for a metaphor or one that's relating to all the students, maybe ask one of your students who already gets it to explain it in their own metaphor, because often the metaphors that students come up with are much more relevant and useful to someone who's beginning as well. One of the things that I have to constantly be mindful of as I'm teaching is that there are a lot of things that I take for granted, both in the words that I choose and the concepts that I employ, because I've been coding for so long. And so I always have to try to have that empathy to put myself in the shoes of my students who are beginners to find the right words and the right metaphors that really connect for them. And sometimes I just cheat and I have another student explain it so that I can hear what they have to say and use that. So, use your resources in the room as well.
Next one, Ju.
Okay. This one, let's see here. Oh, here we go. I skipped over the slide. Okay. This one, this was a mind-blowing discovery to me. And I know that many of you are going, yeah, I get it. I know, like you've been teaching longer than I have. But when I was a student, we didn't have as many choices in what we learned, right? It was, you're doing this project, or you're doing this assignment, or here's the thing that you're going to do. Occasionally you would get to choose your own subject or your own topic for an essay, but it was really not, the choice wasn't a part of this. And what we found is that when students have choices, it does 2 things. One, it makes it an authentic learning experience for them because they have agency and choice over what they want to learn. And so they're more inclined to choose the things that are more interesting to them, more engaging and more useful. The second thing that I think is really important here is that when students have to make choices, that often involves trade-offs. And they have to start to weigh their options. If I go this route, then I have these considerations. If I go this other route, then I have these considerations. And that trading off process that they have to do to make choices makes it really interesting for them because they can't have it all. They don't have enough time. They don't have enough resources. They have to choose something, and they have to choose the best thing for them. And I think that makes it more authentic. It reflects more of what happens in the rest of their lives and in their future lives when they can't choose everything. They can't have everything. They have to choose the best thing at the time with the information that they have.
So you may have all heard, maybe in, I think Esty said this and John mentioned it, these ideas of John Mickton in the past, in the session I just came from, these choice boards. They really helped us during the online learning switch. We made these activities so that students could have asynchronous learning still happening. And they got to choose, say we put 4 boxes of choice, 2 of them were mandatory. Those were our standards. Those are the things that we needed to cover. And the other 2 were leveled in different difficulties, an easier version and a harder version, or a video versus an article, or a game versus an interactive coding program. And this allowed the students to explore all of them if they wanted to, or the one that they felt more connected to. These choice boards, we could put videos on them, and it really just helped not only keep the kids engaged, but also gave them this opportunity to do it on their own time.
Yep. And in addition to that, projects, right? Projects are fantastic in computer science. It's been fantastic during distance learning because, a project in a science class might involve materials or chemicals or things that they have to source and acquire on their own. But projects in computer science often just require your computer and the ability to learn and figure out how you want to do something. So we've created these 2 different kinds of projects. We've done projects that go throughout our course, and we teach for 9 weeks for each student. They have a 9-week course with us. So it'll be a 20%, like 1 day a week, where they will work on a project throughout the quarter. And we've also done a cumulative learning project where they can demonstrate what they've learned over the course of the quarter, which comes at the end. And this is really where they have the opportunity to learn something, demonstrate what they learned, show it off. And the key part here is demonstrate. When we say they have to present, what we get is Google Slides, and it's awful for everybody. But when we say demonstrate and show us what you made, show us how it works, explain it to us, those final demonstrations become much more rich and wonderful, and they talk about things, and other students are asking them questions. Well, how did you do that? Or what is this part over here? And we've seen everything from platformer games where people are jumping along. I had 2 6th graders who set up their own web server and had web pages loading, and it was the first time they'd ever created a web page before. We had 2 girls who the first day of the project, or the second day of the project, they came back the second day and they had written 500 lines of an interactive story that they had created with some guy, I think named Roberto, and he was like your tour guide through the jungle, and he was classically handsome. They loved it, right?
And they just got into Mad Libs and card games, and it's crazy.
Right. And they just have so much fun with it. Okay. I want to just make sure that we're being mindful of time here. So we have about 15 minutes left, and we're going to go through, I think this is the last one.
One more.
There's 2 more. We're going to try to go through those relatively quickly so we can leave time for questions and discussion and conversation at the end, because we love hearing what you guys are working on, what you like, what's working well, what really connects with you and resonates. So we're going to make sure we leave some time for that. So if we go through these last 2 a little bit fast, it's not because they're less important. It's just being mindful of time.
Okay. So this is another favorite of mine, and it's this desirable difficulties. Dr. Bajork, learning strategy, came up with this idea that we need to find these challenges for our students that are actually at the level that just out of their reach, just that amount of stress that doesn't leave them crying in a corner, but makes them so frustrated that they want to really finish it. And we talk a lot, and this kind of goes in hands with this mindset idea and this high level expectations that we both put on our students. We give them these desirable difficulties in order to deeper their learning. And it's that level that makes them actually process and retain the information more. And it was a hard change for us, because we had to slow down and give up some of the concepts that we wanted to teach, because allowing a child or allowing a student to really sit with this discomfort does take time, and it takes a lot of emotional support as a teacher. Sometimes I feel like more of a mentor than a teacher. I'm not the sage on the stage, but I'm this person that's saying, I know you got this. How are you going to solve that problem? What can you do in order to find out about X? And that's what these desirable difficulties do for us.
Right. It's something that I've always found interesting. If things are too easy for students, they become comfortable, right? And they do the same thing over and over again. They don't stretch, they don't expand. It's like a rubber band, right? And if you just leave it loose all the time, it becomes hard and it cracks. But if you stretch it and you keep stretching it, it stays flexible and it expands to do whatever you need it to do. So this desirable difficulty means that our students have to stretch themselves. They have to try to go a little bit beyond what they know. And without going to the point where they're so far stretched that they feel like they will never be able to do it. So it's also on us as the teachers to individually look at each student and see where they have come from and what they're doing now and how to help them get to that point where they're growing without breaking. Okay.
So going into some of the strategies, again, you have to sort of build up to these desirable difficulties. You have to encourage this struggle time. A lot of the kids, we give them this one platform that we use. It's called Code Challenges. And they have many tiny little chunks of information challenges. So one chunk is like on variables and the other one's on conditional statements. And a lot of times when they submit and they failed, it's this freak out moment. I can't do this. I can't do this. But having the child or the student go back and say, I can't do this yet, but I'm going to give you time. I know I said it's due today, but if you need more time to sit with this, if you need more time to process this information, just let me know. Send me an email and I will extend your time. And we've really learned to let go of always grading at that moment. It was a hard turn for me. I'm an ex-science teacher. We got to go, we got to get the curriculum, we got to do it. And it was something that it took a lot of time for me to just let them have that struggle time. And it's changed the learning environment for us.
And here's a concrete example of that kind of right range of desirable difficulty. So one of the beautiful things about this coding platform is that we can see how long students are taking to solve each problem. And so on average, when a student is doing really well and they've got a lot of momentum built up and they've figured out their own process for solving these, most of these take between 5 to 7 minutes to read, digest, apply, make a few errors, and then find the solution. So I tell them, if you take 20 minutes on one of these challenges, right, that's okay. Like it may take you longer to figure it out. You may be struggling with it a bit, and that's okay. But if it's taking you an hour, I want you to come talk to me. Like, come ask me questions, because you're not actually making progress if you're working on this for an hour. So we try to look at it both in a time amount, like how much time are they spending on it? And then how much progress are they making? Are they just spinning their wheels, their figurative wheels? We want them to struggle for a certain amount of time. We don't want them to struggle forever. It's better if they come to us, because then we can point out something that they may have missed, or ask them to read it again in a different way, to read it out loud so they comprehend it. Some of those strategies will help them quickly come back up to speed on that momentum for solving the challenges and acquiring the information.
And this is not something that you come in on day one and you say, hey, you're going to have this desirable, difficulty and you're going to work on this. It's something that we've built up, and we build it up really fast. We have 9 weeks with the students. And in the 6th grade, that's like, it's mind blowing that they have these challenges, but we are constantly working on the seek and retrieval recall. What is this? How do you do that? And it's something that we build into our code alongs, our activities during the day. And we also like to interleave. This is another thing that Dr. Bajorek brought in with his learning strategies. We like to interleave these topics. So we'll spiral through, variables through the 9 weeks, but we'll also put in other activities and other concepts that allow their brains to make these bigger connections.
Right. Another thing that's important too is to make this a regular feature of your classroom, something that is routine. We start off a lot of our classes with these, go take 10 minutes to try to solve one of these problems, so that every time they're with us, they start off by having a bit of a struggle at the beginning and overcoming that, so that it's okay. For the rest of the class, if you're struggling on something, it's okay to struggle, because we will help you get through it from this point onward. But they start every class with that. So we make it a routine and part of our class's ritual. Okay? And in order to do that really well, you also have to know your students, right? So you have to know what they are capable of doing, what they're not capable of doing, what may be beyond them right now. And we also put yet into our own vocabulary. They're not ready for this yet. And sometimes they delight us with how fast they overcome that yet and get to the next thing, because they've figured out how to overcome the struggle so well.
And one of the hard struggles that we've actually, and I'm sure a lot of you might have experienced as well, is how do we make these connections and how do we get to know our students online? Because we have half of our students online and half of our students in the classroom. And it's, again, taking that time and realizing that sometimes covering the content faster, it's not going to help us in the end. So getting to know that Johnny doesn't process things when he reads, that he needs to have me or someone else read to him, is something that takes time. But if you do it straight in the beginning and get to know your students straight away, then you can help design those desirable difficulties for them. Okay, next one.
Okay.
It's you.
All right. And this is something that is near and dear to my heart, because I think this is really, in the time that I left school to the time that I became a teacher, my value to whoever I was working for or with was my ability to figure things out and to be independent and self-sufficient. One thing that I still think about today is a conversation I had with my very first boss right out of college. And I was at a very big corporation, and he gave me a project to work on, and I said, okay, what does the final product look like? What's the answer here? What do you need me to, like, what am I shooting towards? And he says, I don't know. That's why I hired you, right? So I want you to come back to me when you've got it halfway figured out, and then we'll make sure that you're on the right track and heading in the right direction. And then that way we'll know when you get to the final product. So this idea of figuring things out is something that we view as a really vital, durable skill for students to be able to learn independently, to be able to figure things out, to be able to achieve things, to be able to accomplish goals, to be able to be valuable to themselves and to those around them, to have this sense of competency and knowing that they're going to figure this out. And this really rolls up a lot of the other things that we've talked about here too, in that you have to draw upon a lot of these skills and traits and resiliency in order to be able to figure things out. And we haven't come up with a better term than just being able to figure it out. So there's some strategies that we've employed that we see helps this a lot along the way.
So if you're familiar with Will Richardson and the RQT, the right question technique, that's something that's been dear to my heart, and something that I always, as an educational coach, was something that I always pushed into other classrooms, the science classroom, the humanities classrooms, even foreign language, having this this answering the questions with questions idea. When a student will ask me, well, why do you have to do it this way? My favorite line is, well, what do you think? And it's just making them continually ask why questions. And if they come up to me or Sean and say, what is a variable? And I'm like, that kind of sounds like a question you can answer on your own. You go back, ask me a question that's going to be difficult. Don't ask me a question that you can find out on your own. And those are these figure it out things that Sean and I like to say a lot. It is, again, you have to know your students, because sometimes we'll say figure it out and it turns into she's not teaching me. You're supposed to be a teacher. And I'm like, I'm a facilitator, so go figure it out. and that's what we do.
Right. And I think there's an important emotional support that needs to happen here too, because students can sometimes feel shut down when you tell them, like, well, go figure it out. And what I usually add to that is, I know you're capable. I know you can do this. I know you're smart enough to figure this out, and I know that you will. and it may take some time. So you have to give them that time. You have to make it so that there's time in the classroom where they have room for this figuring out to happen, for them to make it make sense in their brain, for the neurons to arrange themselves as needed, right? And so giving them that time to sort it out is really important. Kelly was, kind of not quite yelling at me the other day, but she was like frantically waving at me at the back of the classroom because I was just powering through this code along that we were doing, or coding together, and she said, "You have to slow down. They are not getting it. They're barely keeping up." And I said, "Kelly, I know that." I said, "And this is my learning. I want to know what happens when I go too fast, because I need to be able to see it. I need to be able to recognize it. And today they're going to be my guinea pigs, right?" So you have to give them that time to figure it out. And now I know what that looks like when they don't have it. I can see the signs of it. So I needed that kind of learning experience myself.
So the other thing is, you need to, we joke a lot that we're the facilitators, we kind of push them in the right way, but we are teaching our students how to swim in this deep end. When we tell them to go figure out things, it's always with some sort of guidance. So when you're there figuring out, did you read over that one text that we gave you? How about looking at that code that we did yesterday? Do you think that's going to help you solve this problem? So even though they feel that they're, like one of our colleagues says, jumping in the deep side of the pool without learning how to swim, we are teaching them the techniques in order to swim to the edge of the pool, at least to get out of the deep end.
Right. And then they can go from that stage into other things, right? One of the things I love about teaching them to swim in the deep end is, when I learned how to code, Google was just coming out, right? And so most of us had these big red books published by like O'Reilly or something like that, and it had everything you needed to know about the language that you were trying to learn. But the only thing you could learn was what was in the book, right? So you're limited to the 450 pages that author thought was important. But our students today have an ocean of information available to them, tens of thousands of pages, often a lot of those wrong or incorrect or a bad way to code it, right? But they have to learn how to sort that out. They have to think about, is this good information? They have to find their sources. They have to know how it's good. And we guide them through that as well. But when we talk about the deep end, they're swimming in an ocean of information these days, and helping them build the skills to be able to navigate that, to be able to, figure out how to just back float to start and then to start swimming is a great skill for them to learn. And we believe it's a lifelong skill, because it's not like we're going to have any less information tomorrow or the year after that. There's always going to be more and more information. It's growing exponentially, and we have to help our students learn how to navigate that.
Okay. So while we were picking out this presentation, we were arguing over the ones that we wanted to share, and we were just trying to pick 6. We have so many more that we've really just have loved and worked with: the critical thinking and information literacy, perseverance and coaching. And I'm just going to read them all, Sean, sorry. And active learning. I'm writing a blog right now about how we use active learning with our code along, so that we're not just sitting up there lecturing our code and it's a code and copy. We're making these active learning moments. And it's been a huge learning journey for us. We started off, I was copying code and I was like, wait, kids, you can't ask me that question because I don't know it yet. And to what we've become now. And we have the benefit of having to teach the same curriculum 12 times a year because we have a quarter class. So we've been really using that power of reflection and learning theories and learning strategies to see the learning happening, making it visual.
And the very gentle advertisement for our podcast is, at this point, we've done at least one episode of our podcast on each of these topics. So if you want to learn more of our thoughts about that, the whole backlog is available. You're welcome to listen to those. And as we go forward, we may come back and revisit some of these topics, because we continue to learn and evolve our thinking about each of these areas too. So these are things that are constant topics of conversation between Kelly and I. And I think most of us probably have the same thing, with our colleagues as well.
So we're going to leave it open for questions. I do want him to show I think I put show them a fun one. Oh yeah, and the quotes. So this was from one of my 7th grade students. I taught her in 6th grade. She came in and was like, I can't code. I hate coding in 6th grade. And I just thought, when she said this to us, I said, you have to write that down. You have to email us. And you can just read from her. It just changed my feeling of how I want the kids to remember computer science. I personally don't care if they go and code Python for the rest of their lives, but what we do teach, I want them to take it into their other classes. I want them to realize that we're there for them. We believe in them, that we have high expectations, but we have high expectations for them to be the person that's going to change the future. So
right.
A lot of expectations on
no, really, really small expectations. Just change the world. It's fine. A couple things came to mind for me as I became a teacher, and there's many, many reasons why I became a teacher, but there are a few things that are important to me. We teach most students about science, even though they're not going to be scientists. We teach students about languages, English, right? And in the hopes that they'll be better communicators, even if they'll never write a book one day. We teach students foreign languages for countries that they will never visit, right? So computer science is something that every student can benefit from, because the reason why we teach all of these things is because they have benefits beyond the subject area. Okay? The other reason that's vitally important to me, and one of the reasons why this is something that is my purpose, is because education is an enabler for students, for people who do not always have the same opportunities as everyone else, for people to change the trajectory of their lives. And it has been recent, relatively recent, but I think this will continue. Technology, coding is a differentiator for students. It can really make a difference in their life and be one of those things that changes the trajectory, not because they've learned this particular programming language or this approach, but because of all the other skills that it teaches them. It teaches them to be successful and to be able to be persistent and to have confidence in themselves, and all of these things that are really important. So, as much as I love programming and technology and everything, the bigger picture here is that coding is one more tool for students, and the things that they learn while they're coding are the really valuable parts. Those are the things that help them become something more than they ever thought they could be.
Put in the slide. I mean, we have 12 more minutes for questions. Oh, wait, go back to that one. Sorry, I'm not in control. This is what happens. So there's 2 videos. No, the resources. This one? Okay. There are 2 videos. Maybe it was my fault, and you can learn anything. I found these videos. I don't remember the website. Sorry, but they're good motivational videos for mindset. And it's something that I show in my advisory for my 6th graders. You can access these links. This presentation is on the Live Curious website. And those are just 2 of the episodes about figuring things out, where we actually brought in one of our science teachers and our American government teacher to hear how they also employ the figuring out method. And then show them the having fun slide at the end. We're not going to say it, but we do. One more. No, yeah. So I just look at this girl's face. This is what we're talking about. We take that time, and unfortunately we can't do this in COVID right now, but Sean gave these kids a drone, which he learned not to do in class anymore. But that was his first or second year. And just this, how did you make that work? And I can code this in Python. That is what we do to, besides coding, but it just to build that curiosity. So questions, I won't talk anymore. If there's anyone
questions, conversations,
we'll turn on the gallery so we can stare at everyone.
Yeah, I'm going to stop sharing here and we can go to the gallery view. But let's talk about this. What were the things that stuck out to you? What are some things that you can take away? We'd love to hear the things that you want to go use in your classrooms that really stood out to you.
Or the things that you're doing in your classrooms, because we are constantly wanting to learn more. So that's why we present, not really for us to talk for an hour. Sorry. Karen, you have any? No, I think I saw you in my breakout room. No.
I would like, hi, my name is Patricia. I'm from Monterrey, Mexico. And thank you very much for your information. It was lovely. And great things that you mentioned here that we can take back to our classrooms. I have a question because here in Monterrey, we haven't gone yet. We're still online. And I heard that you're working on a hybrid mode. How do you do that with students back home, using the devices in the classroom, students being back home? How do you manage that?
I'll take that. I loved online learning. I think I'm one of the few people who was like, oh my gosh, I don't want to go back to regular school. In computer science, I had more time for the kids. I had to learn a lot of stuff last year really fast because I ran out of curriculum in my 7th grade. So unfortunately, I do sit down at the desk a lot more, but we have our kids in the classroom sometimes log into Zoom, and it gives them ability to do a lot of debugging. So we have the kids at home on Zoom, and a lot of the times I'll say, oh, Johnny at home, can you put on your code and let's see what you got? Or they say, I have a question and I can't find this error. And then it's like a game. The kids in the classroom are like, I'll spot the error. I know. And they jump up and they want to talk to the camera and spot the debugging. So we've been managing a lot with that sharing screens activity. And that's one thing I'm afraid of losing. And I don't know how I'm going to implement that later on. So
I think there are some really nice tools that are coming out to help with that screen sharing and collaboration. From just a classroom management perspective, one of the things that our school did very well at the start of this was to establish all the things we would need for a hybrid learning model in terms of technology, resources, and everything. So every teacher has a Zoom account, so we are all using that, and I know that's fairly standard, but we also have large screens in each of our rooms, which we had before the pandemic as well. But then one of the things we added was high quality cameras in each of the rooms with good speakers. So we found that, surprisingly, the audio ability, the ability to pick up, voices clearly and distinctly in the room was just as, if not more important than the quality of the video that we're sending. So we use these cameras to try to break down the walls between the virtual learners and our classroom learners. And then it's up to Kelly and I to spend as much time as we can trying to connect the students, to be able to ask questions of the students that are at home, the students in the room, get them to work together, share information. Oh, Billy, you had this question about this bit of code. I think Annika remotely had that. Annika, can you share your screen so they can see that? So a lot of those tactics to try to bridge between the two seem to be working very, very well. And I would admit I'm not perfect at it. I find myself putting too much attention to the students in the room sometimes, too much attention to the students on the Zoom. So I'm always trying to reflect and think, am I giving everyone their fair share of attention and engagement in the room?
And the other thing that works well with the hybrid is we change the views a lot. So if I have a rule, if you see my face, I see yours. But I always tell them, we talk a lot here in this conference, but in the classroom, we don't talk as much. So if you don't see my face, you can turn off your video. And a lot of the times the kids at home are saying, I can't listen to the video because I have screencasts. We give them videos to listen. So we mute the kids in the classroom. And I tell them, listen, I'm going to put you guys on mute. If you need me, we're here for you. Just shout out. And sometimes I have to tell the Zoom kids to stop talking so much because they feel more part of the classroom because we've given them that interaction with seeing the kids working, seeing me, seeing the screen, and it's the change up. Okay. Great question. Thank you.
With a few minutes left, are there any other questions?
No.
Elisa, you came on video. Do you have a question for us? No? Okay, just checking. And what are some of the things, if you want to put it in the chat, if you don't feel like, actually, let's do that. Everyone put one thing in the chat that you want to take back to your classrooms. So just type it out. It can just be a few words, doesn't have to be elaborate, but just some things that you're going to take back to your classrooms or to your schools from this presentation things that may have been useful to you.
And
we'll give you.
Wait, go ahead, so Patricia.
Sorry, but I'm asking another question. But
I love it.
In my school, we teach Python, but like in higher levels, in high school. And from what I see, you're experts in Python. And at what age do you suggest that students start learning Python? Because I've seen or I heard that you were talking about 6th graders, 7th graders, but if that would be like not acceptable when I was thinking about Python. So what is your?
Our curriculum starts in 6th grade with Python. I teach all 6th grade and half of 7th. Sean teaches half of 7th and all of 8th. And we have 9 weeks with the 6th graders. I teach Python 3 full text concepts, 4 weeks. Then I do 3 weeks of Python Turtle library. And then the last 3 weeks, depending, because sometimes it's not really 9 weeks, the last 3 weeks I use the BBC microbit. So I'm doing that spiraling effect of the basic concepts, and I teach them variables, F strings, conditional statements, functions, all those basic concepts in 6th grade. But we've also had 4th graders that I taught in the summer school with the BBC microbit in Python. Yeah. There's a really, I'm sorry, one second. Go ahead.
Yeah, go ahead.
There's a really cool thing. Sorry, I'm going to talk anyways. There's a really cool thing called EduBlocks, which is a block Python that you could give to 4th graders. Go ahead, Sean.
Yeah, you stole my thunder. That's what I was going to say, is that our lower school teachers use a lot of Scratch and Scratch Junior, this block-based visual coding. But there's this amazing program called EduBlocks, which was invented by like a 13-year-old. It's block-based coding, but it translates directly into Python. So you can click between the block view of the code and the Python view of the code. And it's a really nice bridge between that visual coding to text-based coding. And so if you have students who are ready, if they are hitting the limits of what they can do with block-based coding, EduBlocks is a great way to help them move, because they can see all of the different options for themselves with the Python language, and then see how that turns into the text-based code.
And this kid, he's now 18 or 19. If you Google him, we actually interviewed him a long time, 2 years ago.
Yeah.
He said that he designed this because he says kids my age hate writing a lot. So there were no block Python. I mean, they have it, but it's not that good. But this is real Python code. You can write your Python blocks, flip to the Python view in text, and it's spot on. You can't go back and forth, but you can see it afterwards. And what a brilliant kid. I'm hoping we get more kids like that. He's from England, so we didn't teach him, unfortunately. All right, we have 1 minute. So it was amazing. We love Tinker too. We kind of got rid of Tinker because they weren't keeping up with the levels. So we use Code Challenges. It's a brand new program that we helped with we helped the developers make a school platform. So if you're interested, you can just tell them that you heard from us. They have a lot of desirable difficulty challenges. So I got to shush up because we have 1 minute and I want to let you guys get your break. Thank you so much, Monica, for being a great facilitator of our meeting. And thank you guys for coming.